In this video, we're going to talk about displacement and distance traveled by a perimetric vector. Suppose a particle moves along a path in the plane so that its velocity at any time t of v of t is v of 1 of t and v of 2 of t, where v of 1 represents the x component and v of 2 represents the y component. And v of 1 and v of 2 are both integrable functions of t. The displacement, which is the final minus initial, if you remember, displacement is final minus initial position. From t equals a to t equals b is given by this vector over here. Remember, displacement is change in position. It's not the total distance that particle traveled. In order to find the total distance traveled from t equals a to t equals b, you got to find the absolute value of velocity from a to b, which is the magnitude. Therefore, square root of quantity v1 t squared plus quantity v2 t squared. And note that dt is outside the radical. Let's take a look at some examples. It says a particle moves in the plane with velocity vector v of t equals t minus 3 pi cosine pi t, comma 2t minus pi sine of pi t. At t equals 0, the particle is at the point 1, comma 5. Part A says find the position of the particle at t equals 4. Now remember, displacement is final minus initial. We have an initial position right here. When t equals 0, the point is at 1, comma 5. Our final position is when t equals 4. If we are able to find the displacement, since we have initial, we could also find final. So how do you find the displacement? You know that the displacement is going to be integral from 0 to 4 of the x component of the velocity, comma, integral from 0 to 4 of the y component of the velocity. Now, you could do this with your graphing calculator, and you're gonna end up with 8, comma 16. Make sure you try it on your own with your graphing calculator, and you should get 8, comma 16. Now, since displacement is final minus initial, you could say that our final position will be displacement plus initial. So what is our final? It's going to be displacement 8 plus, what was our initial? It was 1, comma 5. So it's going to be 1, and then it's going to be 16 plus 5. So our final position is going to be 9, comma 21. Again, our initial was, when t equals 0, it was at 1, comma 5, and displacement is 8, comma 16. So in order to get our final position, it's going to be 8 plus 1, comma 16 plus 5. So our final position of the particle is at 9, comma 21 when t equals 4. Now, what is the total distance traveled by the particle from t equals 0 to t equals 4? Well, in order to find the total distance, it's going to be integral from 0 to 4 square root of v1 squared, so which is going to be quantity t minus 3 pi cosine of pi t squared plus quantity 2t minus pi sine of pi t square, and then make sure you put dt outside. Again, you could do this with the graphing calculator, and when you do it, you're going to get approximately 33.533. Of course, it's better to have more than 3 decimals to be safe. And right now you should use your own graphing calculator and see if you get this value here. Now let's say they want us to determine the path that the particle travels going from 1, 5 to 9, 21. Now notice 1, 5 refers to when t equals 0, 9, 21 refers to when t equals 4. And in order to find the path, we need to find the position from the velocity. So we have dx dt equals t minus 3 pi cosine pi t, and dy dt equals 2t minus pi sine of pi t from this given information here. So now we're going to find x of t and y of t by taking the antiderivative. So when you take the antiderivative, you're going to get t squared over 2 minus 3 sine of pi t plus c. Notice, you probably have to use u sub, or you could just kind of get the antiderivative right away. When you take the derivative of negative 3 sine pi t, you are going to get negative 3 pi cosine of pi t. Now, how do we find the value of c? Well, when t equals 0, x is 1. So x is 1. When t equals 0, plug in 0 for t, you're going to get 0 over here. You're also going to get 0. Therefore, c is 1. So you end up getting x of t equals t squared over 2 minus 3 sine pi t plus 1. Now we've got to find the antiderivative of this. So this means y of t is equal to integral of quantity 2t minus pi sine of pi t, and don't forget dt. So when you find the antiderivative of this, you'll get t squared plus cosine of pi t plus c. Antiderivative of 2t is t squared. And notice, when you find the derivative of cosine pi t, you'll get negative. And then derivative of pi t is pi, and sine of pi t. If you want, you could use u sub as well. Now, how do you find the value of c? Well, when t equals 0, you know that the y value is going to be 5. So 5 equals 0, and cosine of 0 is 1. So it's going to be 1 plus c. This means that c is going to be 4. So therefore, y of t is going to be t squared plus cosine of pi t plus 4. So therefore, this is going to be our position vector. And now all we got to do is use this to graph the perimetric curve from t equals 0 to 4. And when you do that, you'll get graphs something like this, setting your windows from negative 5 to 15 and 0 to 23, where t equals from 0 to 4. And make sure you confirm it with your graphing calculator.